Let's finish by then. Should we start? Have y'all already started? Yes,
Yeah,
sir.
I already started. We're good.
Hello.
Okay, cool.
Okay, so question 3, is that where we're
Yeah.
starting?
Yep.
Okay, when you're taking a sample size of n equals 5, what shape of the distribution of means of the histogram when the parent population is skewed right?
So this would be skewed right
Yeah, that's
because
what I thought too.
the sample size isn't greater than 10. Oh, 30, right?
Yeah. And so
Okay.
isn't it when it's like not normally distributed, when it's like right skewed, it's smaller, but when it's normally distributed, that means that everything has to be everything's normally distributed?
Yep.
Is that right?
So
Okay.
for it to be normal, it has to be above 30 for sample size or what you just said.
Okay, sounds good.
So number 3 would be right skewed.
Yep,
4 would be normal,
Yep.
right?
Mhm.
Over 100 sample size.
Yep.
5 would be, okay, so this is normally distributed, so it's going to be normal.
Normal, yeah, that's what I got too.
Okay. Normal. So
Yep.
over 100. Okay.
Yep.
So number 7. Do you want to just read through all those bullet points?
So if it's over 100, it doesn't even matter what the parent population size is, right?
If it's
Yeah, it
anything
doesn't.
over 30, it doesn't matter.
It doesn't matter. Okay, cool.
Hey, Carl.
Hey.
So Carl, we kind of already started, but do you want us to go over question 3? Because we're on question 6 right now, or 7.
Yeah, probably.
Okay. It's super easy. I mean, it's not like complicated.
Okay. So for number 3, when you're taking, are you there?
Yeah, I'm here.
Okay. So when you're taking a sample size of n equals 5, what is the shape of the distribution? So, since the parent population is right skewed and the sample size is less than 30, it's going to follow that parent population, so it's also going to be skewed.
So it's gonna be skewed right.
Yeah.
Alright.
And then number 4, the sample size is over 30, so it's normal.
Right.
Number 5, the sample size is less than 30, but the distribution is normal, so it's also going to be normal.
Right.
And then number 6, the sample size is over 30, so it's going to be normal.
Okay. That's
And that's
pretty
just how
simple.
it's about.
And so.
Okay. Go for it, Kendall.
Do you want me to go? I
Yeah.
can read it. Okay. When the distribution of means, when would the distribution of means be normally distributed? 1, data are drawn from the population that is normally distributed and the sample size is small. True.
Yep.
Data are drawn from the population that is normally distributed and the sample size is large.
Yep.
True. Data are drawn from the population that is right skewed and the sample size is small. No. Is that right? That would be no.
Yeah, that would be no.
And then data are drawn from the population that is right skewed and the sample size is large. That would be true.
True.
Yep.
Who wants to read this next one?
I got it. Which of the following gives the best explanation of the central limit theorem? A, if the parent population from which the data are drawn is normally distributed, then the sample mean bar x will follow a normal distribution. B, for bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean, about 95% within 2, and approximately 99.7 within the third. If the sample size is large, then the sample mean x bar or bar x will be close to the population mean standard deviation. And if the sample size is large, the shape of the distribution means will be approximately normal.
Isn't it the last one?
Yeah, that's what I have.
Yeah.
Yep.
That's right.
Okay. So 9. Basically, with all that information, what is the mean of the distribution of sample means?
So that's just asking basically the mean, right?
Yeah, so that's like that's 10.
Yep, so 10.
Did you guys get 10?
Yeah.
Okay.
Yeah.
Yes, I got 2.
What's the standard deviation of the distribution of sample means?
6, right?
I got 1.
I got 1.
Oh,
Yeah.
okay, wait, how did you guys get that?
So this is where you plug in that equation n over the square root of,
Oh, I see.
oh no, standard deviation over the square root of the sample.
Uh-huh.
So it'd be 6 over the square root of 36.
Oh, which is 1.
Yeah, I got 1 also.
Awesome.
Okay. Number 11. Regardless of the distribution of the population, if the sample size is large or greater than 30, what would be the shape or distribution of the distribution of the sample mean?
Mm.
Normal?
Yeah.
Okay. And then what theory would justify your response for that? That would be
Which
I
one?
think central limit theorem, right?
yeah.
Yeah. Didn't know that one very well.
I think it's central limit
I
theorem.
think it is too because that is non-specific and it goes towards any population.
Okay. That makes sense.
But let me submit it and see what it is. Yeah, it was a central limit theorem. We got them all right.
Oh, good.
Hello.
Sound good?
Yep.
Great. And guys, I had one question on the prep.
Yeah.
What did you guys say for part 2, number 7C? Do you understand that question? I guess it depends on what you mean you got, but
Part 2, number 7. Which one?
7A?
7C.
7C.
So my mean that I got was actually pretty dang low. I just guessed bad, I guess. But what did you say?
Mine wasn't really low, it was like pretty close to the mean. So I just put, no, it wasn't unusual.
Yeah.
You guys are both close to the mean?
Yeah, I know.
Yeah, mine was.
How many times did you do it?
I just did it once, so maybe I'll just do it a couple more times and then use those. Yeah, I don't think it's that important. I understand what they're asking, so.
I think that's good rationale. That's what I would say.
Yeah.
Okay, well, I think that's it, right?
Yeah, I think that's it.
Yep.
Okay. Kylan, will you submit it?
Yeah, of course I'm doing it now.
Okay. Thank you so much.
Okay.
Yeah, you guys rock. I'll see you Wednesday.
Wednesday,
Yep.
6:30.
Yeah, Wednesday me.
Also, I super appreciate how short these meetings are, like how efficient they are.
I know.
All right.
I'll
Sounds
see you
good.
later.
Yeah,
All
see you
right.
guys.
Bye.
Bye.
Bye-bye.